Hello, everybody, again. Hope everybody is home and safe, doing well, enjoying a little free time, some downtime, some time with our families. I know I'm spending plenty of time with my family, sometimes a little bit too much in terms of keeping some sanity here, but seeing everybody. Hope everybody is well. We're gonna, continue on with Module 7. What I wrote in the Skyward thing is that we're not going to test on Chapter 6 with it not counting, with it not being something that can hurt your grade. I don't know if it's worth putting on a big test or whatever, but we will continue on into Module 7. So if we do get back together next week, we'll hopefully be able to hit the ground running with the topics that we should be covering. So going through with a geometry theme here, and just going to do some prereq skills, some things that I think you know already, but things that you need to know pretty well moving forward in this chapter. So if you just kind of follow along, I will have these attached to the review. If you can print them out, just follow along. Hopefully all this is a review for you. If you just kind of go through number 1 here, it says a radius is a segment that connects the center of a circle to a point on a circle. And then number 2, when we start talking about a diameter, so just some definitions, that's our radius. And a diameter is a segment that connects 2 points on a circle, but also must pass through the center of the circle. So number 3, just real quick on the right, name the segments that are shown. So this guy here is our radius. And then this connects, since this is connecting 2 different points on the circle and they go through the center of the circle, this is our diameter. Okay, so we should know that. Then what we fill in the blanks here is the diameter. If we just looked at our picture, this hopefully is pretty obvious, is always going to be twice as long as your radius. Okay, things that you've talked about before with circles, the idea of circumference. So when we start talking about the circumference of a circle, it's basically the perimeter of a circle. So the perimeter of a rectangle are the outer edges, like how long around a rectangle, how long around a pentagon, whatever. That's your perimeter. Well, the circle, since it's one shape, all right, it's circular all the way around. We don't have sides. It's just all kind of one side. It's called circumference. So that is the distance around your circle. Okay. So the circumference, and again, if you don't remember this, it should be 2 times pi times your radius. Okay. Or if you understand that we set up here, our diameter is always twice the radius. If you see right here, here is twice the radius. So we could also write this as that pi. And instead of doing 2 times the radius, we could just multiply that by our diameter, because the diameter is the same as twice your radius. This is typically the one that I like. All right, 2 pi r, that's one that you're going to see most of the time in most textbooks, problems, all right, so on and so forth. Okay, we also can do the area of a circle. The area of a circle is pi r squared. That's the amount of space covered by a circle, basically the space inside of the circle. Okay, since it's an area, we have 2 dimensions. All right, we would always do feet squared, meters squared, inches squared, versus the circumference where it's just inches, meters, miles. Okay, so a couple simple problems here to get going. It says find the circumference and area of each circle. We're going to leave our answer in terms of pi, so that means we don't have to throw this into our calculator and round. So our circumference, again, the one that I like to use is 2 pi times your radius. If we look at this figure, we can see that the radius is what's drawn in here. That's our r. We throw in a 5, and we would say that our circumference is 10 pi, and this was 5 inches. So our circumference is 10 pi inches. Area is pi times your radius squared. The radius is, again, that segment shown, 5 inches. And we need to square that. So 5 squared would be 25, then your pi. But notice how your unit of inches is also getting squared. So this would be 25 pi inches squared. 8. Circumference is 2 pi times our radius. If you've noticed now, what I've given you here is your diameter. So we would know then if the diameter is 7, that means this is 3.5, and then this side would also be 3.5 for our radius. So we just multiply by 3.5 feet. 2 times 3.5 is 7 pi feet. Area of a circle, pi r squared. All right, our area is pi multiplied by this particular radius, which is 3.5 feet. We throw that into our calculator, and we should get 12.25 times pi. The unit would be feet squared. All right. We'll still deal with some similarity statements and similar figures in this chapter. So just a little review of this. If I gave you that this segment, I don't know what you would call it. And so 1, 2, 3, 4. We can call that a pentagon. It's not a regular pentagon where all of the sides are the same, but certainly has 5 sides. We want to take those 5 sides and just write a similarity statement to the second one here. So if we remember what we talked about before we had gone on our little break here, whatever A is, since that's the first term here, we need to find the corresponding angle in the second one, in this one. So if we look at our shape here, V should be the one that corresponds to A. So that's got to be listed first. They went to B. B is down here. So B's corresponding angle is Y. See how many colors I can come up with here. We then went to C. So here is C. Its corresponding angle is W. D was next. Its corresponding angle is what? R. So that's going to be very thick. That's bad. That should be R. So let's just write R in there. No need to be too fancy here. It's not terribly difficult. And then Z is there, or E is their last one. So the corresponding angle in that smaller version was Z. All right. If we do our sides, same idea that we would have dealt with when we were together. If we can go ahead and find E to A. So here is EA. We went from here to here. So that means we went from Z to V. A to B would have gone in this direction. So we're going to go in that direction from V to Y. B to C, we're going here from B to C. So we do the same thing down here. That would take us from Y to W. C to D. So that's us going from here to here. So that means we're going to go from W to R. And then our last one, D to E, would take us from R to Z. So pretty simple stuff we've talked about before. It's all going to come back to us though. Next page, when something has a full rotation, then we say that it rotates 360 degrees. So last year, in Math 1, you would have done a lot of angles of rotation. We know we can take any figure, rotate it 360 degrees, and it always will reproduce itself. When we rotate it halfway around, then obviously we just take that 360 from the previous problem. If we only go halfway, then it's said to have been rotated 180 degrees. Okay. Some things below here. Name each shape shown below. This is a square, obviously. A couple things with this. Obviously, this is obviously, if you don't remember, it's a pentagon. But if we look at it, this was drawn so that all of these sides are congruent. So we could say down here, this is also a pentagon. It's not the pentagon that you think of, but as long as I have 1, 2, 3, 4, 5 sides, we can call that a pentagon. It's a shape that has 5 different sides to it. That's also a pentagon. This is more what you're going to think of a pentagon. This is what you would have called last year a regular pentagon, where all the sides are congruent and then all of the angles are congruent. So we do want to put regular here. So with this one, these are all the same. These are intended to be. This is what we would call a regular. We have 6 sides, hexagon. All right, for 15, let's count them. 1, 2, 3, 4, 5, 6, 7, 8. So that is a regular octagon. 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is a regular decagon. All right, the whole decade indicating a 10. So regular decagon. And then 3, this is a triangle. The reason we're marking these just so we understand anything with 3 sides is a triangle. But if it's a triangle that all 3 sides are the same, we would want to throw, hopefully I left a room here, equilateral. So equilateral triangle. Okay. And then the last thing here, find the perimeter and area of each shape. So with a square or rectangle, if we just want our perimeter, that's all the sides added up. So this has to be 10 inches. That would have to be 13 inches. We add all those up, 10 plus the 10, and then the 2 13s added up. Say 26, 36 should be 46 inches. All right. When we do the area of a rectangle, that's our base times our height. So for us, that's 13 inches multiplied by 10 inches. So we would say our area is 130, and then this unit multiplied by this unit gives us in inches squared. Last but not least, notice how this is not a regular shape where we have some different shapes kind of thrown in here together. So we'll have to think a little bit here. We're going to break this up so that we can figure out if we want the perimeter. We don't know what this length is. We don't know what this length is. But if we break that up into 2 rectangles, so we'll call this rectangle number 1, this is rectangle number 2 here, then we should be able to kind of figure out what this segment is going to be. So if we look up here, let me change colors, this full length here is 22 feet. So if I could look now down here, this segment here, and let's do blue, this segment here, purple I guess, should add up to be 22 feet, all right? Because it has to be the same as the one that's up here. So if the purple one and the red one add up to be 22, we know what the red one would have to be. So if we look down here, since this is 8, that would have to be 8. And since the purple and red would have to add up to be 22, what that would tell us is this has to be 14. So that 14 added together with our 8, there we go, should give us our 22. We have to do something similar for this side here. We don't know what that side right there is, and we're going to need to know that. So we do something similar. We now know from here all the way down, that's our 30 feet. If we look across here, we see that from here to here, let me do that in yellow, the thick yellow. Here to here has to be the same as here to here, so that we would know that this here has to be 12 feet. And since this is 12, that would make this guy 18, so that 12 and 18 would add up to be this total of 30. And then we can come back over here and say that that is also going to have to then be 18. Okay? So by doing that, we can come up with all the sides and lengths that we need. So now let me clean this up a little bit. Get rid of the stuff that we don't need. Get rid of this. We don't really need that. Don't really need this. All right, but then we should be good now. All right, so yeah, and this we probably don't need for what we're going to be doing here. And yeah. All right. So now let's go ahead and find our perimeter. I'm going to take this side, 22 feet. I'm going to add it to this side, which is 12 feet. This side here, which we found to be 14 feet. Side here we know is 18. Side there is 8. Hopefully I can squeeze this last one in. And then this full big side is 30 feet. Okay. Add all those up. Give me a minute. And we should get our perimeter to equal 104 feet. Okay. If we want the area, again, we're going to have to split this up into 2 separate little problems. If I wanted the area of this guy, we need its base multiplied by its height. So that is going to be 8 times 18. So that's a 1 here. Kind of looks like a 7. So 8 times 18 would give us 144 feet squared. So let me put that in there. So this here has an area, let's do that in red, of 144 feet squared. Then we would still need to figure out what was the area of this big rectangle here. So if I did that, I'm running out of space. Let's do that below. This has a height of 12, and then this whole length here would have to be the same as this length up here. So my base is 22. The height is 12. So we do base times height. So 22 times 12, again, give me a second. 264. We then know that is the area of this rectangle, 264 feet squared. Add those up. So 144 plus 264 should be a very nice 408 feet squared. So add them all up. 44 equals 408 feet squared. Okay. Hopefully that's pretty straightforward. Again, I'm going to try to keep this reasonable as we go through this. Keep the videos pretty short, the assignments pretty short, pretty basic. We won't dive into this too deeply when we're doing these online, but at least as we move along, if we get back together, or if we don't get back together at any point, when you see this again in the future, or this chapter, it's going to be stuff that you've seen that will hopefully come back to you and you'll know the basics. Anyway, miss everybody. Hope everybody is doing well and is safe, and hopefully we'll see you all again soon.